A nation's capital sinking 5 centimeters each year, factories paralyzed by thirst, 600 million people facing the death of their land as groundwater vanished and the North's lifeline looked doomed. In one audacious gamble, China set out to carve a massive artificial river through desert and mountain, defying nature, displacing hundreds of thousands, and risking everything. But just how close did this staggering rescue come to total disaster? North China's dry plains stretch for thousands of kilometers, but the crisis is measured not in distance, but in numbers. 600 million people live in this region, nearly half the population of China, yet they share less than a tenth of the nation's water. The land beneath their feet is sinking. In Beijing, the ground drops 5 centimeters every year as wells reach deeper into the earth, chasing water that once sat just below the surface, but now lies 40 meters down. The city's thirst is relentless, but supply has vanished. The North China Plain, cradle of ancient dynasties and modern megacities, produces a quarter of China's entire economic output, yet it holds just 8% of the country's water resources. For every ton of steel, every bushel of wheat, every new apartment block, the demand for water grows. Factories line up for rationed supplies. Farmers abandon fields as aquifers run dry. In summer, the air shimmers with heat. Temperatures above 100 degrees Fahrenheit are common. Dust storms sweep across Hebei and Inner Mongolia, stripping topsoil and pushing the desert ever closer to the city edge. Some years, rainfall drops to a fraction of what is needed. Reservoirs shrink to mudflats. Urban water quotas fall to as little as 100 liters per person per day, a fraction of what most cities in the world take for granted. In the worst-hit districts, families collect water at dawn from communal taps, filling buckets for washing, cooking, and drinking. Children grow up learning to count every drop. Yet 1,200 kilometers to the south, the Yangtze River pours nearly 1 trillion cubic meters of water to the sea each year. The contrast is brutal. A river so vast it floods fields and towns, while the north withers. The imbalance is not just a matter of hardship. It is a threat to the economic engine of a nation, to the survival of its capital, and to the lives of hundreds of millions. Drought is not a passing hardship here. It is an existential pressure, measured in vanishing meters of groundwater, lost harvests, and the slow, silent collapse of the land itself. At the dawn of the 21st century, China's leaders faced a reckoning. The numbers left no room for doubt. If water could not be brought north, the heart of the nation would falter. In 2002, the State Council gathered behind closed doors in Beijing and delivered a single, sweeping verdict. The South-North Water Transfer Project would go ahead, no matter the cost. The commitment was staggering. Over $62 billion allocated, the largest sum ever pledged to a water project in human history. This was not a single canal, but a vision on a continental scale. 3 separate routes, each with its own obstacles and ambitions. The eastern route would modernize the ancient Grand Canal. The central route would carve a new channel for gravity to do its quiet work. And the western route, still a dream, would one day cross the wild high plateau. The decision set in motion a mobilization unlike any before. Survey teams fanned out across the countryside, drilling boreholes as deep as 30 meters into the earth. Each sample, each centimeter of soil, was logged and measured, building a map of the unseen world beneath China's rivers and deserts. Engineers pored over satellite data and topographic maps, tracing possible alignments with the precision of surgeons. The fate of millions and the promise of future generations would depend on their calculations. Every detail mattered. The project's institutional machinery, ministries, committees, and design bureaus became the driving force. Their mandate? To turn a political decision into a living system, one that could carry water across 1,000 miles of hostile terrain. The scale was daunting. Planners had to account for shifting riverbeds, seismic zones, and the needs of cities that did not yet exist. Contracts were signed, budgets approved, and a new era of engineering began. Behind the scenes, debates raged. Conservation advocates warned that moving water was not enough, that efficiency and restraint must come first. But the urgency of the crisis left little room for caution. The machinery of the state moved forward, powered by the conviction that survival required action on a scale never attempted before. The South-North Water Transfer Project was no longer an idea. It was now the central protagonist in a national drama. With a cast of thousands, a budget that dwarfed entire provinces, and a mission to rewrite the fate of a continent. Earth movers and surveyors converged on the hills above the Han River, where the Danjiangkou Dam stood as both gateway and barrier. The plan was audacious: raise the dam by 14.6 meters, flooding valleys upstream and unlocking the gravitational force needed to drive water north. At full height, the reservoir's surface reached 176.6 meters above sea level. That single decision set the starting line for a channel that would run 1,432 kilometers, nearly the distance from Madrid to Berlin, without a single mechanical pump. Gravity alone would carry the Yangtze's water across mountains, plains, and deserts, through the heart of the nation's industrial north. Precision mattered more than brute force. The canal's slope was engineered to drop just 1 centimeter for every 100 meters of distance, an almost imperceptible grade, but enough to keep billions of cubic meters moving. Survey teams spent months mapping the route, drilling boreholes up to 30 meters deep, and marking every meter with GPS. Any miscalculation risked stagnation or overflow. The channel itself stretched 150 feet wide and 23 feet deep, a man-made river carved with a patience that rivaled nature's own. At the peak of construction, crews hauled away 70,000 tons of earth every day. The logistics rivaled those of wartime mobilization: fleets of excavators, convoys of trucks, and armies of workers advancing meter by meter. Each segment demanded its own solution: cutting through bedrock, shoring up loose sand, or bridging ravines. The numbers tell the story. 219 rivers and streams crossed, 1,774 separate structures built to keep the flow uninterrupted. Aqueducts soared over valleys, culverts slipped beneath highways, and spillways tamed seasonal floods. Behind the technical blueprints stood the lead engineers at Danjiangkou, charged with balancing ambition against the realities of terrain and time. Their challenge was not just to design a canal, but to orchestrate a living system, one that could flex with earthquakes, withstand drought, and carry water reliably to cities hundreds of kilometers away. Every step was measured, every risk calculated. The margin for error was razor thin, and the consequences of failure would ripple far beyond the construction site. As the backbone of the central route took shape, each milestone brought new obstacles. The canal had to maintain its perfect slope across shifting ground and variable geology, passing beneath highways and over rivers without losing a drop. With the groundwork in place, the greatest challenge still lay ahead: crossing the Yellow River, where the Earth itself seemed to conspire against every plan. But for now, the Gravity Canal stood as a testament to methodical ambition, a silent river waiting for its first surge of southern water. The Yellow River is no ordinary obstacle. It carries more sediment than any other river on Earth, over 1.6 billion tons each year, churning its bed into a shifting maze of sand and silt. For the water transfer project, crossing it meant going beneath, not around or over. 2 parallel tunnels, each stretching 4,250 meters, were bored 40 meters under the riverbed. Shield tunneling machines, custom built for this task, advanced through pressurized sand and groundwater. Every meter brought fresh risk. The river above pressed down with a weight that could crush concrete. Sand lenses threatened to burst, and a single misstep could flood the entire tunnel in seconds. To survive these pressures, engineers designed a dual-layer lining, an inner ring of reinforced concrete and an outer protective shell. Between them, a permeable barrier helped absorb shocks from earthquakes and river shifts. At each joint, grout was injected and tested to withstand 6 atmospheres, enough to hold back the river's force even during spring floods. Borehole logs revealed unpredictable patches of gravel and clay. When sand ingress threatened to overwhelm the machines, crews froze the ground ahead or pumped in more grout, working in shifts around the clock. Each day's advance was measured in centimeters, not meters. After 9 years, the final segment broke through. In the control room, the chief tunneling engineer ran a hand along the cold concrete, knowing every seal would be tested by the river above for generations to come. On the eastern route, the challenge was mechanical. Water had to be lifted uphill, fighting gravity for hundreds of kilometers. Engineers installed 23 massive pump stations, their combined power reaching 453 megawatts. Each station could raise water by 40 vertical meters, enough to fill a city reservoir in hours. The pumps ran in sequence, synchronizing flow across the line. Sensors watched for pressure drops, vibration, or leaks. Any sign that a valve had failed or a bearing was wearing out. When summer storms hit the Central Plains, power lines flickered. Backup generators stood ready, but the system's dependence on electricity was always a risk. Operators trained for emergencies, running drills that simulated grid failures or sand blockages. Waterproofing the canal itself was a feat of logistics. Along more than 220 miles of channel, crews rolled out high-density polyethylene geomembrane, anchoring each sheet with steel and covering it with 4-inch thick concrete slabs. Each section measured 16 by 10 feet, fitted together with hot bitumen to seal every seam. The operation was relentless, lining, pouring, and curing day after day in heat and wind. On the embankments, workers planted vetiver grass and desert acacia to hold the soil, fighting back erosion with living roots. For all the triumph of breakthrough and first flow, the system's vulnerabilities lingered. Every tunnel, pump, and liner depended on constant vigilance. A blackout, a mist leak, or a shift in the riverbed could threaten the entire line. In the end, the artificial river was not just an engineering marvel, but a living system, one that demanded as much care and attention as the rivers it sought to tame. On December 12, 2014, engineers at the Danjiangkou Reservoir opened the intake gates. At first, the water crept northward, a controlled test of just 500 cubic meters per second, monitored by teams stationed along the channel. Sensors tracked every movement. Technicians checked for leaks, measured pressure, and watched for signs of erosion. Gradually, the flow increased. In the days that followed, the current grew stronger, reaching 6,000 cubic meters per second. The artificial river, silent for years, carried its first surge of southern water into the heart of the north. The effect was immediate. Reservoirs filled in Beijing, Tianjin, and dozens of towns across the North China Plain. For the first time in decades, water levels began to rise. By 2024, the South-North Water Transfer Project had delivered 76.5 billion cubic meters of water to the north, enough to fill more than 30 million Olympic swimming pools. The system now sustains 185 million people. In Beijing alone, the project supplies 1.2 billion cubic meters every year, meeting a third of the city's total demand. The city's groundwater, once in free fall, showed signs of recovery. Wells that had run dry began to refill. In Tianjin, factories restarted production lines that had stood idle for months. In Hebei, farmers returned to fields abandoned during the worst years of drought, planting wheat and corn where dust storms once raged. Celebrations broke out as the water arrived. In Beijing, families gathered at Tuancheng Lake to watch the first clear water pour into city reservoirs. Some called it the day the North came back to life. The relief was not just practical, it was emotional. After years of rationing, after summers spent lining up at communal taps, the promise of steady supply felt like a new beginning. For millions, the arrival of southern water meant more than survival. It meant hope for the future and a chance to rebuild lives in a land that no longer had to fear thirst. For the Li family, the arrival of southern water brought more than new reservoirs. It brought the end of a way of life. Their village in Sichuan County, like hundreds of others, vanished beneath the rising waters of the Danjiangkou Reservoir. 3 generations packed what they could carry, leaving behind fields, graves, and the stone house where Li Jing's grandfather was born. Promised new homes and steady jobs in the city, they boarded a government bus to Zhengzhou. The apartment was clean and bright, with running water and a view of distant towers. But the farmland was gone, and the factory jobs never came. Li Jing's grandmother, once the matriarch of a close-knit village, now spends afternoons in a concrete courtyard, surrounded by neighbors she barely knows. 15 years on, the family has found stability, better schools, a city hospital, and a future for the children. Yet, for the older generation, the sense of rootlessness lingers, a quiet ache for the vanished hills and the graves that could not be moved. The Li family's story is echoed by hundreds of thousands. In total, 345,000 people were relocated for the water transfer project. Compensation was often delayed or fell short of what was lost. Some families received less than half the land they once farmed. Promised training and new livelihoods rarely matched the reality. Social ties, woven over centuries, were torn apart in a single season. Surveys show that older adults and rural women suffered most, struggling to adapt to city life and unfamiliar work. For many, the pain is not just economic, but cultural. Ancestral villages erased, family graves submerged, festivals and rituals lost to memory. The river's reach extends beyond human boundaries. Downstream from the Yangtze, reduced flow has allowed salt water to creep inland, poisoning fields near the estuary. Fish populations in Dongting Lake have fallen by nearly 30% since the first diversion. Scientists warn that altered currents and rising salinity threaten fragile wetlands and the species that depend on them. Critics argue that the project treats the symptoms, not the cause, diverting water while industrial waste and overuse continue unchecked. The unbuilt western route, planned across the earthquake-prone Tibetan Plateau at altitudes up to 5,000 meters, remains stalled by risk, cost, and international tension. The future of China's water, and the fate of those who live along its artificial rivers, is far from settled. Today, northern China's industries and cities depend on water that flows against geography and history. Yet the cost echoes in uprooted lives and fragile ecosystems. As demand rises and climate strains old solutions, the world watches. Will engineering keep pace with nature, or must ambition finally yield to limits? Every drop delivered north is a wager on what the future will allow, and what it will refuse.